In April 1815, on the island of Sumbawa in present-day Indonesia, a mountain that had been quiet for centuries began to change. Mount Tambora was not considered dangerous. It had no recent history of eruption. Local records described it as inactive. On April 5th, a violent explosion shattered that assumption. Ash rose into the sky. The sound was heard hundreds of kilometers away. Most observers believed the event was over. It was not. On April 10th, Tambora erupted again, this time with a force unmatched in recorded human history. The eruption lasted for hours, then for days. The summit of the mountain collapsed inward. A massive caldera formed. The mountain lost more than a kilometer of height. Hot ash, gas, rock, molten material. They surged outward in all directions. Entire villages were erased. Forests burned. The coastline was reshaped. Tens of thousands of people died immediately. Many more died in the months that followed. This was not only a local disaster. Tambora expelled an enormous volume of material into the atmosphere. An estimated 60 million tons of sulfur dioxide were injected into the stratosphere. Far above weather systems, far above rain. Once there, the gas spread around the globe. Sulfur dioxide reacted with water vapor. It formed sulfate aerosols, tiny particles that reflected sunlight back into space. The effect was not visible at first, but it was measurable. The planet cooled. Not gradually, abruptly. By late 1815, sunsets across Europe and Asia began to change. The sky turned red, purple, orange. Artists painted them. Observers recorded them. They did not know the cause. In 1816, the effects became impossible to ignore. Temperatures dropped across the northern hemisphere. Rain increased. Frosts returned in seasons when they did not belong. This period would later be called the year without a summer. In New England, snow fell in June, and again in July. Crops that had sprouted were killed overnight. In Vermont, farmers woke to frozen fields. Corn collapsed. Beans blackened. Fruit trees failed. In Quebec, snowstorms were recorded in June. In Pennsylvania, rivers froze briefly in summer mornings. Europe experienced the same disruption. In Ireland, relentless rain destroyed the potato harvest. In France, grain prices rose sharply. In Switzerland, famine spread through mountain regions. Food shortages were not isolated. They were widespread, connected, systemic. The climate anomaly did not last a week or a month. It persisted. Average global temperatures dropped by an estimated 1 degree Celsius. That may seem small. It was not. Agriculture operates within narrow limits. A few degrees determine survival. Harvests failed repeatedly. Stored food dwindled. Prices soared. The poorest populations suffered first. Then others followed. Historians estimate that hundreds of thousands died worldwide as a result of the climate disruption, not from lava, not from ash, but from hunger and disease. The cause was unknown at the time. No one in Europe knew the name Tambora. No one connected the cold rain in Switzerland to an island volcano halfway around the world. Science did not yet have the tools to make that connection. People searched for explanations. Many found none. The gloom was constant. Skies remained overcast. Sunlight was dim. Days felt shorter. In the summer of 1816, a group of travelers found themselves trapped by the weather near Lake Geneva. Among them were Mary Shelley, Percy Bysshe Shelley, Lord Byron. They had planned outdoor excursions, walking, boating, conversation. Instead, they stayed indoors, day after day, because of rain. To pass time, they read, they talked, they challenged each other to write ghost stories. Mary Shelley began writing a novel, a story shaped by isolation, by unnatural forces, by fear of creation and loss of control. She would later publish it under the title Frankenstein. The novel was not caused by Tambora, but the conditions that made its creation possible were cold weather, dark skies, persistent confinement. The same conditions affected millions who would never write a book. In Germany, crop failures pushed food prices beyond reach. Bread riots erupted. Governments intervened, often too late. In China, weakened monsoons disrupted rice production. Floods followed drought. Famine spread across provinces. In India, altered rainfall patterns contributed to the spread of cholera. The disease moved along trade routes, reaching regions it had never affected before. This was not one disaster. It was a chain. Tambora changed the atmosphere. The atmosphere changed weather. Weather changed agriculture. Agriculture changed society. One consequence appeared in transportation. Before 1816, horses were essential. They powered farms. They moved goods. They carried people. They also required grain. During the food shortages, grain was redirected to humans. Horses starved. Many died. Others were slaughtered. In parts of Europe, transport systems collapsed. Goods moved slowly. Trade stalled. In Germany, an inventor named Karl Dreis responded to this problem. In 1817, he introduced a two-wheeled human-powered vehicle. It had no pedals. Riders pushed against the ground with their feet. It was called the Lauf machine, the running machine. It is widely regarded as the precursor to the modern bicycle. The invention did not replace horses immediately, but it represented adaptation. When food for animals disappeared, humans compensated with muscle. Again, the connection was indirect. No one invented a bicycle because of a volcano, but the conditions created by the eruption made the invention useful. Science would take decades to understand what had happened. In the mid-19th century, researchers began studying volcanic eruptions systematically. They noticed patterns. Large eruptions were followed by cooler years, by crop failures, by unusual weather. Tambora became a key case study. Ice cores taken from Greenland and Antarctica would later confirm it. Layers from 1815 show sharp spikes in sulfate concentration, a chemical fingerprint of volcanic aerosols. Tree rings tell the same story. Growth slowed dramatically in 1816. Across continents, across species, written records align with physical evidence, temperature logs, harvest reports, personal diaries. The signal is consistent. Tambora caused global cooling. It remains the largest volcanic eruption in recorded history. Measured by volume of material expelled, measured by atmospheric impact. Later eruptions, such as Krakatoa in 1883, were dramatic. They were smaller, their effects were shorter. Tambora altered the climate for years. The eruption reshaped the mountain. Before 1815, Tambora stood over 4,000 meters tall. Afterward, it stood closer to 2,800. Entire ecosystems were destroyed. It took decades for vegetation to return. Some areas never fully recovered. Local cultures were erased. Languages vanished. Archaeological remains were buried under meters of ash. These losses were largely forgotten outside the region. The global effects were remembered, but not understood. The phrase, "the year without a summer," entered history books, often without explanation. Modern climate science now places Tambora within a broader framework. Volcanic forcing, aerosol reflectivity, radiative balance. These mechanisms are well understood today. They are also relevant. Tambora demonstrated that Earth's climate can change suddenly, without human influence, without warning. It also demonstrated vulnerability. Societies dependent on stable weather are fragile. When that stability breaks, consequences cascade. In 1816, there were no global food reserves, no rapid transport, no coordinated response. Local failures became global crises. The lesson was not learned immediately, but it was recorded. Every major volcanic eruption since has been studied with Tambora in mind. Scientists monitor sulfur emissions. Satellite instruments track aerosol spread. Because the atmosphere remembers, the cooling effect eventually faded. By 1818, temperatures began to normalize, harvests recovered, societies stabilized. But the losses remained. Graves, abandoned farms, collapsed economies. Mary Shelley would later reflect on the summer that never came. She described the darkness, the cold, the sense of unease. She did not know the cause, but she felt its weight. Tambora never erupted again on that scale. It remains active, but quiet. The year without a summer was not a metaphor. It was a measurable climate anomaly, caused by a single geological event, on a single island, in a single year. Its effects crossed oceans, altered history, and then passed. The ash settled, the aerosols dissipated, sunlight returned. But for 1 year the planet cooled. Crops failed, ideas formed, technologies shifted. The record remains, in ice, in trees, in books, in machines. The eruption of Mount Tambora did not announce itself to the world. But the world recorded its presence in cold rain, in empty fields, in darkened skies. The year without a summer was not mysterious. It was physical, chemical, and temporary. A reminder that the climate is not fixed, and that small changes in sunlight can change everything.